So, because we started the video late, well, for those listening at home, we have to re-explain. Part one, it was defined when a is bigger than or equal to 0, because you need the inside to be positive. And then these ones in part one are all like terms. So 6 root a's plus 5 root a's would give us 11 root a's, minus 11 root a's gives us 0. Now in part B, where is it defined? Since the a squared is inside is always a positive number, it doesn't matter if it's positive or negative. There's no restriction on a. However, for b, b would have to be bigger than or equal to 0 because you have all positive numbers in there already, so b would have to be positive as well. We have to simplify this, and I'm going to show all my work. So for root 50, I'm going to break that up as root 25 and root 2, and then for my variables, I'm going to break that up with a squared and b. Minus, with the root 8, I'm going to break that up with root 4 and root 2, and I have a root a squared and a root b. Square root of 25 is 5. Square root of 2, I can't do anything with. The square root of a squared is a. However, a square root is always positive, so we need to make sure that that a goes in absolute value box. And the square root of b, we can't do anything with. Minus 2 root 2. This will also be absolute value of a. So what I really have, when I put this together, I put my numbers out in front. So my numbers out in front are 5 absolute value of a, and my square roots that I'm left with, I can put those together as 2b, minus 2 absolute values of a, and square root of 2b. In order to put these together, not only do they have to be like radicals, but they also have to be like terms. Can you see that these are like terms? As far as the variables go and the radicals go, I'm going to put a box around this part and this part. Can you see that what's inside those green boxes are exactly the same? So I have 5 green boxes minus 2 green boxes. Does it make sense? I'd be left with 3 green boxes. In other words, I have 5 absolute value of a square root of 2b minus 2 absolute value of a square root of 2b. Those are like terms, so I would be left with 3 absolute values of a square roots of 2b. And then in part C, again, they're cube roots. So when we go to define, this is the one, oh, this makes you so happy. If it's a cube root and it's asking where it's defined, life is easy. Everything can be anything. So p can be everything, and the other variable is q. Q can be everything. Because you're allowed to cube root negatives, you're allowed to cube root positives. So for where this is defined, everything works. Are they like terms? Not yet. Okay? Cube root of 27 is 3. But I'll break it up. So I have cube root of 27, then I'm going to have cube root of p cubed, and cube root of q. I'm breaking it up. Plus I had an 8. On the other one I have cube root of p cubed, and cube root of q. Cube root of 27, on your powers chart, that is 3. Cube root of p cubed, that is just going to be p. Because cube rooting gets rid of cubes. Okay? And then we have cube root of q left. Plus 8, cube root of p, that'll be p these like terms? So again, I'll put all my variables and all my radicals inside of a green box. Are those green boxes the same? Yes, they are like terms and like radicals. I have 3 of them plus 8 of them. That will give me 11 of them. So I have 11 p cube root q's in the end. Now, I showed all of my work, but as you get good at your mental math, this is probably what I would expect. I'm going to just add an extra question here. You can add it as well. Let's say I have the square root. Oh, I'm going to make this interesting. Let's go. I'm just picking the square root that I want to deal with. Say we have this. I have 54 a to the 5 b to the 7 plus ab times 24 a cubed b to the 5. First of all, this one is a little bit interesting for where it's defined. Either both of them have to be positive, or both of them have to be negative. Does that make sense? But what I really want to do in this question is show you a little bit of how you can simplify a little bit of mental math, and sometimes showing less work actually makes you make less mistakes. First of all, I want you to recognize this is 9 times 6, and this is 4 times 6. So because this is 9 times 6, I know that I'm going to be able to pull out a 3, because the square root of 9 is 3. And for my variables, because what I'm doing right now is I'm trying to pull out everything possible. For my variables, I'm going to be able to pull out an a squared and a b cubed. Because 2a squareds would give me a to the 4. 2b cubes, or b cubed times b cubed, would give me b to the 6. What am I left with? I'm left with the 6. I'm left with 1a and 1b. I like to do it all at once with mental math. Shows a little bit less work. But you can double check. If you put this back inside a square root, you see that you would have b to the 6. Plus 1 more b gives me b to the 7. An a squared in a square root would have to be an a to the 4. And a to the 4 times a gives me a to the 5. The 3 inside a square root would be square root of 9. Square root of 9 times square root of 6 is 54. And then I would have plus 24. I can take out a 2. I can take out another a multiplied by this a gives me a squared. I can take out another 2 b's times by this b, b cubed. Leaving me inside, I took out a 4, I'd leave me with a 6. I took out another, leave me with a, I took out 2 b's, leaves me with another b. And these are like terms. So 2 of them plus 3 of them will give me 5 of them, leaving me with the square root of 6ab. technically, whichever one you use, I'm going to put absolute values around the b cubed, because it would have to be positive in the end anyways, when you pull it out. For this to work. A little bit complicated with the variables, a little bit complicated with the absolute values. Try questions 5 and 7 right now to get some practice in.